Hey everyone, so here's the second question which is based on traps, DS traps. So once again we'll start by actively reading the question stem first, and then try to solve the question without having any biases while going through these statements. Okay, so let's get started. So let's start with the first step, that is jotting down what information we have from the question stem. It's given that P and Q are positive integers, so we'll write that down, PQ positive integers. Okay, that means the values can be 1, 2, 3 and so on and so forth, or you can even write P and Q are both greater than 0, whatever you are comfortable with, as long as you know that they are positive integers. It's also given that P is equal to 4Q minus 3. Okay, and we need to find out the GCD of, which is the greatest common divisor of P and Q. Okay, so we have one information about P and Q, a relation of P and Q. We know they are positive integers, and we need to find out the GCD. So some of you may at this point of time try and put values of Q and try to figure out if for one particular value of Q, what is the value of P, and then you may do some kind of hit and trial. But it doesn't make much sense at this point of time to do anything because this statement obviously is not sufficient and there's not enough information with us to do any hit and trial at this point of time. So we should directly move on to the second step and start analyzing these statements. So let's go to step 2 and let's look at the first statement, which is Q is equal to 3K, and where K again is an integer. Okay, so Q is equal to 3K. We can substitute the value of Q in this expression and write P as 4 times 3K minus 3. And then we can write P is equal to, if we take 3 common, we'll get 3 times 4K minus 1. Okay, so now we know Q is equal to 3K and P is equal to 3 times 4K minus 1. So if you want to find out the GCD, one thing is for sure, that since they both have 3 in common, the GCD will at least be 3, right? The only confusion that you may now have is that if Q is equal to 3K, which is 3 times K, does K and 4K minus 1 have anything common or not? So that's the question that we need to think and answer. Now one way is to put values, substitute some values of K and check it. That's one way of doing it. The other way is to think in this way: if they have anything in common, okay, then ideally, and again K is an integer, so keep in mind, if K is an integer, we multiply it by 4 and subtract 1. Obviously 4K minus 1 is greater than K, right? So think in this way: if I take 4K minus 1 and divide it by K, if they have any common factor, they should cancel out, right? But notice, from the numerator, you cannot take anything common, so the denominator has K and there's just minus 1 here. So as far as taking any factor common is concerned, you cannot take out anything common from here which will cancel out with K. That's one way of thinking. So if I take out K common from here, I'll get 4 minus 1 by K, and here you have K, right? So even if you want to cancel it, K has to be 1, K cannot be anything else. Then only you'll get an integer here. Otherwise you won't get an integer, right? If you are left with 4 minus 1 by K, then K has to be 1. And if K is 1, then obviously the GCD would be 3 times 1, which is again 3. So that's not a problem for us at all, because the GCD is still 3. For any other value of K that we put here, there'll be nothing common between them, and so we can be sure that the GCD of at least 4K minus 1 and K is going to be 1 always. Okay, so in short, we can conclude that the GCD is going to be 3 every time, and hence statement 1 is sufficient. That is why your answer will be either A or D, so you can eliminate the rest of the options. The other way is, if you find this part complicated, that hey, I am not very good with variables, what should I do? And again, the method that I'm going to tell you now is not recommended, to be very frank, because it's not foolproof. But what you can do is you can take values of K and check. So for K is equal to 1, Q is 3 and P is 9. Then you can put K is equal to 2 and then say, okay, Q is 6 and P is 3 times 7. Okay, And this way you can check whether they have anything in common or not, and then finally come to a conclusion after 2-3 values that they have nothing in common. That's one way of doing it. But again, it's not a very highly recommended method, because you can never be sure, because you're just checking a few values. So try and do it the way I have done it. I think that is going to help you out. Now let's look at the second statement very quickly, and let's see if that is sufficient or not. So in the second statement, we are given that P is equal to 3m. Okay, so now once again we'll put this value here and say 3m is equal to 4q minus 3, and here from here you'll get 3 times m plus 1 by 4. So notice once again that p, which is 3 times m, and q, which is 3 times m plus 1, here also we can very clearly see that the GCD will at least be 3. But now once again we'll be worried about m and m plus 1 by 4. Will they have anything in common or not? Now here's a logical way of thinking. If you look at the number line, m and m plus 1 are consecutive numbers, right? Now two consecutive numbers, the GCD of any two consecutive numbers is always 1, and you can check that by putting any value. So for example, if I take 3 and 4, the GCD is 1. If I take 4 and 5, the GCD is 1. If I take 13, 14, GCD is 1. 14, 15, GCD is 1, because they two consecutive numbers, they do not have anything in common. Okay, if two numbers do not have anything in common, even if I divide m plus 1 by 4, which will be somewhere here, okay, so basically you're cancelling out some factor from m plus 1 and 4. You're cancelling something out. Okay, but whatever will be left will obviously not have anything in common with m, right? Because m and m plus 1 do not have anything in common. So even if you cancel out 4 from the numerator denominator, whatever is left will also be not common, and hence you can be sure that the GCD in this case will also be 3 times 1, which is 3, and the correct answer in this case would be option D. Once again, if you find this confusing, you can always take value and check it. Here, keep in mind that m has to be odd, and because q is an integer, so you have to put values in such a way that m plus 1 by 4 gets cancelled out properly. So maybe you can think of a value, say for example 15. You may say m is 15, and so m plus 1 will be 16. See, they don't have anything in common. So, and now if I divide this by 4, I'll get m plus 1 by 4, you'll get 4. So notice, once again, you'll not have anything in common, because 15, 16 do not have anything in common. So that's another way of looking at values and then figuring it out. Hey, statement 2 is also sufficient, and that is why the answer in this case is option D. Some of you may end up marking the answer, and there's a high chance that you may end up marking E. Those of you do that is because you end up assuming that maybe k and k4, k minus 1 may have something in common, or maybe you might think that m and m plus 1 by 4 may have something in common, and you may think, okay, these statements might not be sufficient, so let me end up marking E. So there's a E trap set here. Those who do not do proper analysis may end up marking the answer as E. Some of you who do not do any analysis at all may end up marking the answer as C also, because you'll think, okay, something is given about Q, something is given about P, so maybe I'll get my answer. And that's a very poor analysis. Obviously, ideally you shouldn't do that. So I hope this is perfectly clear how to solve questions like these, how to make pertinent inferences and avoid traps.